Good afternoon. My name is Danny Johnston. I'm Regional Sales Manager with Exenda. I'll be your moderator today. Glad you're here and welcome to today's webcast, Expert Tips for Consistent Online Testing Access from Westminster Public Schools. Now I'm pleased to introduce to you our speakers for today. Joining us is Westminster Public Schools Network Team, Jeffrey Miller, the Technology Manager, and Mark Hansen, who is the Network Administrator. We also have Dennis Smith, a Regional Systems Engineer with Exenda, and I'll pass things off to Mark to kick things off.
Hi, my name is Mark Hansen. I'm the Network Administrator here at Westminster Public Schools. We are a school district of about 20 sites. That's our main high school where our data center is located. And between all of those buildings, we have gigabit fiber. So we've got a really good, robust internal infrastructure, and our challenge has primarily been on the edge, where we have about a 1 gig out to the internet fiber now. It's grown over the years from a couple of T1s to a gigabit. And as it becomes time to grow, we've always seen the bandwidth maxed out on our graphs, and it always seems to grow. More and more things come into our district. We have about 9,000 students and 1,200 faculty that all have district supplied devices and personal phones connected to wireless networks. At any given day, we can see as many as 12 to 15,000 devices on our Wi-Fi. And part of that comes from our one-to-one Chromebook initiative that we've put in place. And we are very, very close to that goal, within a few hundred. Like I said earlier, we were regularly hitting the bandwidth cap, and we used MRTG to kind of watch our network bandwidth, and whenever it got slow, we'd see flat lines at the top, and that would cause critical learning apps to be impacted. When the internet gets slow, the things that need to happen tend not to, and everything gets impacted equally. Videos buffer, and testing gets delayed, and processes are problematic. So we knew we needed something to be able to help us out with all of this. We needed to protect the online testing, which is kind of new to all of our districts, that a timely app for testing is necessary to get that to happen seamlessly. The biggest parts of that were traffic monitoring and identification. We didn't know what was out there that was taking up all this bandwidth. Like I said, we had MRTG just showing us the overall bandwidth and not knowing what's in there, so we couldn't identify it, we couldn't corral it, we couldn't contain it, and we couldn't prioritize anything. We couldn't give any sort of optimization to the online testing platforms. We also needed some ability to control VPN and proxy access so that somebody couldn't set something up at home and be able to circumvent web filters. And also social media is a big sticking point that, lots of people want it, but they want to be able to control it. And we didn't want Facebook or any of the other social medias to monopolize the traffic, so that then other systems, again, testing and educational things, were not as accessible. So we got Exenda through Tom and plugged it in, and one of the things that we were able to do was we found that 75% of our bandwidth was being consumed by YouTube. And that, it didn't really surprise us as much as how do we control this. Now we knew what it was, so we were able to move forward with what we could do. So Jeff will talk about how we took care of that.
Thank you very much, Mark. So like Mark said, we did implement our Exenda, and day one we were a little taken back by how much of our actual bandwidth was being consumed by streaming media, specifically 75% of it on some days being YouTube, which obviously does have its purpose in education, and we do recognize that. But one of the things we needed to do was make sure that we were obviously controlling things that weren't weren't sanctioned by the district, weren't going to be benefiting the students' education in the classroom. We needed to obviously, again, and to reiterate this, prioritize online testing above all else because it's very network sensitive. We needed to improve our overall user experience. When we hit our caps, that was obviously a problem that everything would slow down. And we didn't want to fear our software update today anymore when Apple would release a iOS update and all the student and faculty devices would start to effectively destroy our network experience. So when we did implement the Exenda, starting out at the beginning, we were able to optimize the streaming traffic down to be able to occupy, I believe, a maximum of 60% of our overall bandwidth. So we were able to clear up a lot of our bandwidth for other applications, make sure that it wasn't hogging the whole pipe. We were able to more successfully block applications like Snapchat and, as Mark mentioned, the VPN or proxy access. Snapchat was notoriously bad for the classroom environment and was causing a big disruption, and the web filter wasn't able to adequately handle it on its own. Usually Snapchat was coming out with updates every week or two that would cause that traffic to be allowed through the web filter, and it was always having to catch up. So the Exenda has handled that magnificently by dropping those connections. Throttling P2P has been another huge benefit. When we talk about applications like BitTorrent, we were originally using our web filter to block access to BitTorrent. But what happened with that is it'll either tunnel inside of HTTPS or it will jump around on ports until it's able to successfully connect. The Exenda has allowed us to find a little bit more of a unique solution for this. Out of our gig pipe, we effectively allocate about a kilobyte a second for the entire district to contact and connect to BitTorrent networks. What this allows us to do is create an useless connection for accessing BitTorrent, but it doesn't hop inside of an SSL encryption or hop around ports and be something that we miss. Again, prioritizing the online testing has been one of our biggest ones. We've used several different policies to identify the traffic for access to some of the major testing platforms like Pearson, DRC, and WIDA for access testing. Ahead of testing schedules, we always create rules, verify applications are being consistently identified. And what this allows us to do is we can set effectively the highest level of quality of service for online testing specifically. So we've definitely seen a reduction in interruption or lag during student testing. Loading times have been reduced, and I think it's promoted overall better experience for our district. Since this guarantees the smooth testing, we obviously see a huge reduction in help desk phone calls during the testing windows as well. That makes everybody's life a lot better. The overall user experience improved. When we did hit our bandwidth caps, we would get help desk phone calls nonstop. We didn't have enough faculty to obviously handle the overflow for that. We weren't able to adequately control which applications were being used and effectively had to use our web filter to block access to specific sites or protocols, which caused an inconsistent experience for our users. On days where we'd hit our bandwidth cap, we'd use the web filter before we got the Exenda. So we'd use the web filter to block access to YouTube or other streaming sources kind of as a one-off to reduce our overall bandwidth. And that wasn't an effective way to do it. Again, YouTube is a valuable classroom tool, but having to restrict access to that definitely impacted education for the district. So as soon as we implemented the Exenda and we're able to throttle specific applications and better optimize our network traffic, we created a much better cohesive environment for the students, a lot more consistent experience. So we're not, YouTube's available one day and it's not available the next. So our users have become very grateful that we're allowed to create a consistent environment. And again, we've definitely seen a significant reduction in help desk calls on the heavy usage days. Having our online educational and testing apps optimized above pretty much every other kind of web traffic has created a very, very speedy and consistent environment for everybody. Also, Mark and I definitely appreciate that we are no longer afraid of Patch Tuesday or Apple releasing a new iOS update. Obviously, that can be very bandwidth intensive, and when that happened, we used to have to send out email notifications to all users requesting that they not do it during peak hours or in the district at all. Ever since we've implemented the Exenda, we now cap our software updates application group down to approximately maximum 20% of the bandwidth overall. So updates still do go through, but we're using the optimizer in the Exenda to make sure that they don't overtake all the rest of web traffic. As Mark mentioned, we are also implementing a one-to-one deployment of Chromebooks to our students. That equates to almost 10,000 Chromebooks in our environment. When they need an update, they will go out and they will download that update. That is effectively the way we found the highest bandwidth usage on those updates day. So again, Mark and I don't cringe anymore when we have to deploy updates because the Exenda optimizes that traffic for us.
Real quick, Mark, Jeffrey, I have a couple questions for you. One is, how does the Exenda solution complement your content filter?
So for the most part, like I said, the content filter was ineffective at blocking certain applications. Some specific examples were Snapchat. Open Door is another app that was used to bypass the web filter. And there were a couple others that the students would gain access to, be bypassing the web filter in the classroom. And the Exenda's done a good job working kind of hand in hand with that to block the traffic it's not able to catch. So it's definitely created a safer environment for our students not being able to utilize those applications in the district.
Excellent. Are you guys doing any prioritization for voice or video applications at this point?
Yes, for Skype and
Hangouts,
Google Hangouts, we do some of that. And then we also, again, with video, with the YouTube, it's not really prioritization, but we restrict it to prevent it from monopolizing the traffic.
How are you configuring the access policies for individuals using those devices that you mentioned, the Chromebooks, iPads on the Exenda?
We are currently actually not utilizing that based on an individual user level or policy roles based on the user. For the most part right now, our district's mobile devices, Chromebooks, iPads, things like that are segregated onto their own wireless network. So we do effectively everything, all of our policy rules and things are controlled by subnet more than the individual.
Right. And the district devices are given priority over BYOD.
And that way, with the subnets, that also allows you to identify the devices, whether it's a student or a staff member. Is that correct?
Correct, because, like Mark was saying, we have a guest network, which staff and students are both allowed to connect their personal devices to. And all traffic on that guest network is throttled in a sense that's a lot more heavy-handed than we do on our mobile devices for the district. They always receive priority.
Well, that's good information. I really appreciate that. And right now, I'd like to introduce Dennis Smith. He's our regional systems engineer. And with that, he'll get started with the demo.
All right, thanks, everyone. I'm going to go through a brief demo here of the software. Certainly, we can take a look at anytime you want to look at this software. Just feel free to go out to demo.exenda.com, and you can actually see the same thing that I'm going to show you here today. So to start with, this is our dashboard. If you look over to the left top, you'll see what applications are utilizing my network. You're going to see the top 10 inbound and the top 10 outbound. This kind of gives you a rough idea when someone calls and says, hey, the network's running slow. I can take a quick look here to understand what's going on. Over here to the right, we don't have a lot of data to show, but we do have some link utilization statistics here. Got the top 3 offenders on my network, which all looks like pretty good stuff. SSH, SMTP, and MySQL. Definitely, you can also see that we're getting close to our total here of the bandwidth that we've allocated for this particular setup that we have. Over here to the left side, I've got the recreational, what we've defined as recreational, which would include your games, your instant messaging, social networking, streaming, so on. I can dig a little further down. I can see I've got 12 instant messaging. I can go down here and see that this is MSN. I can get very simple data on, we'll look at inbound, for example. And these are my statistics. These are my host names. These are my addresses, packets, data, throughput, everything that you need to know. We can keep digging down on these to go further and further, but I think everyone should hopefully get the gist of what we're doing. Optimizer, this is where the work actually takes place. This is where we define our policies to shape our traffic. So, for example, we've got peer-to-peer traffic at the very top. You can see that that's pretty much choking it out. We've got 1% to 3% of the bandwidth. We've got all peer-to-peer applications, and I'll show you in a minute how that application group breaks out. But this pretty much says if it's peer-to-peer, we're going to let it make that handshake because it does like to port hop. So once we make the handshake, the host says, hey, everything's great. I'm connected. I'm going to quit trying to look for an open port on the firewall. And at that point, basically don't give it enough bandwidth to do anything. On the other side of that example, I'd like to show you what we're doing for voice. And I'm just picking a few candidates here. In this particular case, we want to guarantee a clear phone call. So we're going to guarantee you 15% of the bandwidth. And if there's nothing else going on in the network, we're going to give you 100%. So here we've done just the opposite. The first policy that we set kind of was a restriction. This one is a guarantee. Applications, we've got over 4,000, and this number grows probably monthly, but every couple of months we add more and more to this particular setting here, but we've got over 4,000 applications here. I heard Snapchat come up earlier, so we'll go find Snapchat. We do have a layer 7 signature for that, as you can see, so we could very easily wrap a policy around that to restrict the amount of data that people get to go to that application. I can schedule things. I can say, let my users, do schoolwork only from 8 a.m. to 11 a.m. And then from 11 to 1 or 11 to 12 while they're at lunch, I could open it up and let them go to Snapchat or wherever they want to go. So it's very simple to set a schedule in the application to do that. I can look at service levels. This is a great one for just keeping different services that you're paying for out there. You can get alerted. You can get auto baselines. You can get all types of information based on information that you would put in regarding that particular cloud type application. HTML response is where I could very simply put in my network usage policy. So when someone does cross the line or go beyond where they're supposed to go, I could send them a message that says, hey, here's the computer usage policy, just for you to reread, look at it, make sure you understand it, and we hope that you don't try to do this again. I don't know that I heard this come up in the conversation, but we do integrate with Active Directory. So it's very simple here to, have a AD pointing device or a domain controller, however you choose to implement. We have a very small footprint file that we put on there that basically goes and grabs the information. So this way I can identify users by name versus by IP address. So these are all the conversations that are going on in my network at this particular time. So I've got a ton of things here that I can look at. One of the things I want to bring out is that any of these screens, I can very simply click that Acrobat icon, and I can generate a report from it. So what would happen there is that in this particular case, you get a report with all this information in it. This talks a little bit about our optimization screen. I've got bidirectional. I've got, look at different things I can look at here to give me information from my LAN data, my WAN data. This is more of a reporting screen for users. So I've got internal users, I've got external users. I can see here the number of packets, the amount of data, the throughput, and the flows. Gabriel here looks like he's got some activity going on, so we can check him out. And we can see here everything that Gabriel's up to. So in this particular case, nothing too horrible. Looks like he's doing what he's supposed to do, so we're not going to bother him anymore. This is our control screen. We've got inbound and outbound showing up again. Again, this is a demo site, so there's not a ton of data. In a real network, this screen would be very populated with information. But you can also see as I arrow over all the lines, we can very simply just figure out what type of inbound and outbound traffic and the peak. And once again, I can create a report. I can schedule a report. I can save a report just simply by clicking on any of these icons in any of these screens that I'm in. Well, let's go back and let's just create a policy. So I created a Snapchat. In this particular case, I'm going to guarantee it 1%. Or for smaller bandwidth networks, I can do kilobit per second. We'll give it a 3 kilobits per second. Under applications, we're going to go find Snapchat. Okay, so now you see I've got it. It's down here pretty low. I would, in a real environment, put this up to probably 15. And it looks like we already have it defined. So, but you get the gist of it. That's how simple it is to actually create a policy for a suspect application. This is our protocol screen. It gives us different transport layer protocols. We can define, we can edit, we can do lots of different things with those. We can create policies around them. We can give them numbers. We can add a new protocol if there's a new protocol in your network that you want to add and take action against, and you could add that here. And last but not least, I'll show you guys the service level agreement. This is pretty cool when you have agreements with Office 365 or some other folks out there that are providing cloud services for you. You could very simply come in here, and once you define what that relationship looks like, you come in and define that policy. And any time that they're out of policy or out of compliance, I should say, you'll get an alert through email that basically shows you, hey, these guys are out of compliance. Click here, go check it out, and see what's going on. The last thing I want to show you guys is the recommendation engine that we have built in. Since all of your traffic flows through our device, as we're looking at it, we're seeing things, and if things show up for whatever reason, it could be the first time we've seen it, it could be something we suspect is a problem, then we're going to give you, up here in this blue box, we're going to show you, hey, we found this, it may or not mean anything to you, but if it does, we're also going to give you, you can click right here to go right into the real-time monitor and go take a look at it. And with that said, that's pretty much all I have to show today.
Looks like we have one question here. What is the effect on network performance, considering there appears to be a lot of inspection going on?
Very minimal. It's not even noticeable in the network. We're doing everything at such a high bandwidth rate that it's milliseconds, and maybe 1 to 2 milliseconds.
Yeah, we agree here at Westminster that the overall impact on the network is marginal compared to the benefits of the being able to restrict the unwanted traffic. It's not like a deep packet inspection. It's really kind of source address, destination address, ports, and additional factors can be put in there. But it's not like a deep packet inspection like an antivirus or anything like that you might already have on your network.
Another question is, can you show how the QoS via VLANs works? Any pros and cons?
Yeah, so basically our virtual circuits, virtual VLANs, whatever you want to call them, this is how we guarantee that. So in this particular case, you may want to create one for your wireless network. You may want to create one for your teachers. You may want to create one for your students. I don't recommend that you create a ton of them on here, but 3, maybe 4 max. And it's basically you can divvy up the student IPs go into this particular VLAN or virtual circuit. The teacher VLANs or IPs go into this particular VLAN or virtual circuit, and then you can apply your rules accordingly. So I think what you're asking is, do I have the ability to change the rules for users? And the answer to that would be yes.
Is there a way to tell when there's a change in the application behavior?
Yes, you can set up a profile to do that, or we can alert you in the recommendation engine either way.
And also a follow-up to that, is there a way you can differentiate between staff and student traffic?
Absolutely. If you can see my screen now, we've got the virtual circuits. I could, for example, take this one and edit it, and I could give it, teacher. Teacher internet. And then I could go over to this one and give it student internet, however I want to define that. And then just, you're obviously going to have your IP ranges defined ahead of time. Then we would go in and apply that IP range to that virtual circuit.
Well, thank you, Dennis. I appreciate that answer. And Bruce, your question on what is the cost, the unit is based upon what the bandwidth is for your internet connection coming into your district or your office. And then also we'd be glad to get you in touch with Tom with EPC and be glad to go into further details, private demo as well as putting some budgetary quotes together for anybody that is interested. Here's some next steps. We really appreciate everybody coming today. Mark, Jeffrey, Dennis, thank you for the great information. A big thank you to EPC USA and Tom Hinchcliffe for sponsoring this webcast. If anybody would like additional information on how Exenda can improve your network and learning applications, please visit us at exenda.com, or you can call us directly at 1-877-4-EXENDA or email us at sales@exenda.com. Thank you and have a great day.